I was told to leave and then come back while that video was playing so I could get a second round of applause, but it's fine. It's fine. No. Don't indulge me. Don't indulge me. All right. Yes, I'm Zach. How's it going? Shout out to all the modems in the audience today. Today I'm going to talk about web components. How many people in the audience have used web components before? Okay, that's about what I expected. All right, that's great. But before we can dive into web components, let's talk about, components, not web components. What is a component? It's a piece of reusable UI, right? They can control their structure, their behavior, their appearance. And here's an example. I'm diving right into code right now. Here's an example from a popular library in use today. You have your component definition up top, and you got your usage down below. And just let me check my ChatGPT generated speaker notes for the reference of this component code. Yes, it's vercel.js. Moving right along. So components have been very popular. Component libraries have been very popular. Here's just a few of them. And yeah, there's no shortage of component frameworks that exist today. But really what I want to talk about is web components. And web components are features built into the web platform, provided for free by web browsers, with the potential to initialize faster and run with less library overhead. So as mentioned, my name is Zach. My website, zachleet.com. I built 11D and maintain it. And I'm also a staff engineer at Netlify. So I don't think most developers will admit this, but we're all social creatures and we're prone to trends, just like any other profession. So what I'm going to do right now is I'm going to dive into what we call in the business social proof. This section is just pure peer pressure. So Microsoft has really dove headfirst into web components in the web component space, and one of their design system implementations is called FAST. And it's really great. They've used it on MSN.com. And over 1,500 teams and/or projects at Microsoft have adopted fast web components in the last 3 years. You can read this great article from Rob Eisenberg, and I'll publish these slides so you can get the full URLs. And web components have been really popular in design systems specifically because they are kind of the chameleon of component systems. They can exist in many frameworks. They're interoperable in many frameworks. And here's just a few examples. VMware has a great one. Google has some. IBM, nobody ever got fired for buying IBM, right? Salesforce. My personal favorite is just this immaculately implemented one called NordHealth, built with 11D. And yeah, it's really great. GitHub uses web components. I'm sure Sid would have something to say about that. And another really great one, I think, that got a lot of big press was Adobe. So they have Spectrum web components, and they actually implemented Photoshop on the web with that. And it's based on Lit. So are web components a thing yet? Here's just a bunch of logos. Hey, we love logos, right? Yeah, imbibe those. Those are awesome. Google Chrome publishes some statistics on the Chrome platform status site. And in April of this year, almost 19% of Google Chrome page loads have used web components. So they're pretty popular. And of the component frameworks that have existed, these component libraries are adapting too. So many components have, you just get the tumbleweed animations, come on. These different component frameworks have officially supported methods to compile directly to web component specifications. So Lit and Stencil are first-party web component libraries, but a lot of the other existing popular frameworks today have mechanisms to compile directly to web components, which I think is great. So what are web components? I'm going to kind of take you through a very raw crash course of how to build a web component from scratch. My experience is I like to know how things work under the hood, so we're going to start from the beginning. And everyone knows in the beginning you have to create a counter. People love counters for some reason. They love buttons. They love clicking the button and making the button increment to the next number. I don't know why this is the quintessential component example that exists, but this is what we're going to build today. And for the most rudimentary and perhaps even the most widely adaptable component definition, we can just put HTML inside of our custom element. So we have our my counter. We'll put a button in there. And this is, technically, it's the default slot. Sometimes this is called the light DOM, but it's HTML. We don't need fancy words for it. So if you want to add interactivity to it, you would use the custom elements registry to define what our custom element tag name is, and we can pass a class into it. There's a few sort of interesting limitations with this. You can't define custom element names that don't have a dash in them. And that's just to protect existing HTML elements from overrides. All right, and so this is just the most amazing JavaScript you're going to see today. It's just we select our button that's in our light DOM. We add an event listener that parses the number inside of the button and increments it by 1. Amazing. And one of the things I like to do when I'm creating components from scratch is I like to evaluate how it looks before the JavaScript is initialized and how it looks after the JavaScript has initialized. This isn't necessarily an indictment of using JavaScript. We just want to know how it looks before and after so we know how it loads on the page. So in this specific example, these two things line up. Hey, look at that, amazing. The button before and the button after looks the same. And this is how I think of layout shift. So when the JavaScript loads, and I like to load my JavaScript as late as possible, it doesn't do any DOM manipulation. It just adds our event listeners. So it doesn't manipulate the elements on the page at all in this example. So we don't have any content layout shift. So this example is server rendered, right? It's using HTML. There's not much to it, but it is server rendered. There's no library JavaScript. There's no component framework overhead. And it's using progressive enhancement without layout shift. So great. Here's an example of a web component that I built called the details utils element. It basically just adds an extra behavior to any details summary elements inside of it. That if it adds additional behaviors, and one of them is you can opt into a close that details element if someone clicks outside of it. Here's another one that's called video radio star. It basically controls video elements inside of the child components of this web component, and it only auto-plays the videos when they're visible. So when you scroll to a video, it will start playing it automatically. Useful for animated GIF examples. Here's another one called island. So if you're familiar with the island architecture that's first implemented at Etsy and sort of popularized by Astro, here's a web components example of that. So any web components inside of this island web component, when they're visible, it will initialize the components and add the event listeners. So it really allows you to really it allows fine-grained control of the web components inside of itself. But the hard part of using this and nested content inside of the default slot is that you have to repeat the HTML throughout each instance of the component, which is not what we want as an authoring experience, right? This is not great. I don't want to have to rewrite button every time. The benefit of using a component is that I shouldn't have to rewrite that. So my first grievance, I don't want to repeat myself when I'm authoring these things. What I really want is something more like this, where my unique content inside of each component instance is the only thing that exists in the component. So to do that, we're going to graduate to level 2 from custom elements to the dreaded Shadow DOM. And so to use Shadow DOM in this way, we can define a template element So all of the content inside of the template is not parsed by the browser at the beginning, and we have to use JavaScript to inject that. But we don't have to repeat ourselves throughout every component instance. So here's the new code that's generated for this. All the old code that we used before is sort of grayed out there. But we do have to add or select our template, get our template content, and append that to our shadow root. So everyone knows how slots work. I probably don't need to go through this, but each counter instance then injects that default slot content into our component instance, and this is all in the shadow DOM. Now going back to our before and after JavaScript examples here, you can kind of see that there is layout shift here, right? Because we've introduced a JavaScript dependency on our template content, JavaScript is required to modify the DOM in that way. So we get layout shift, which is a problem when we're evaluating our web vitals of a page. So Shadow DOM, in many respects, is client-rendered. It requires JavaScript to initialize. But there is no library JavaScript executing here. We get full encapsulation of our content, and then we don't have to repeat ourselves in our component examples. But it is riskier to do in this way because you can get layout shift if you're not careful. Now, one of the tools that in our CSS space that we have to define presentation before and after the JavaScript has loaded is we can use this :defined pseudo class. And this can be great for progressive enhancement. Now, the problem here, and I'm taking these examples from some of the earlier design systems that I linked to, is that this can introduce a JavaScript dependency on the styling of your content. If those custom element registry code doesn't run, it won't become defined, it won't be upgraded in that way, and your page will be empty, which is not great. Here's another one that switches from opacity 0 to opacity 1. So don't do this. So maybe this isn't a surprise to folks that follow me online, is that the next grievance is JavaScript. When we introduce a JavaScript dependency here, it can have impacts on our page performance. So let's graduate to level 3. We're going to go straight to Declarative Shadow DOM. So with Declarative Shadow DOM, we can embed our template inside of our component instance, which then has our template content, and all of this is handled by the web browser itself. We don't need JavaScript to upgrade. So in this respect, we get it's the same example, no content layout shift from similar to the first example that we showed, which is great. Now, currently, this just shipped in Safari 16.4, but is not yet supported in Firefox. So you do need to use a polyfill for this. Now, this limitation will go away as time moves on and Firefox adds support for Declarative Shadow DOM. But just be aware of that, and you don't need to understand this code. I've just included it here just to show you how small the polyfill is. This is the entirety of the polyfill. But it does introduce a JavaScript dependency in Firefox, which is not great. So we can have server-rendered code. All of our templates are included in our component instances, with the exception of JavaScript, or the exception of Firefox. Again, there's no library JavaScript here. There's no overhead to implementing these components. We have full encapsulation, and we have progressive enhancement without layout shift, independent of Firefox. But again, we're repeating ourselves. All of these component templates have to be embedded in every single instance, which is, in many respects, a worse authoring experience than the first example. So we don't necessarily want to, you especially don't want to, every time you author code, copy and paste these template instances in every single instance of your component. Now, one of the benefits of using Shadow DOM is that you get scoped CSS for free. So Declarative Shadow DOM and JavaScript-based Shadow DOM, you can embed a style tag inside of your template, whether you inject that with JavaScript or use the declarative method, and you get full scoped CSS. This example is limited to just the component instance, even though we have a star selector there. And you can also use CSS inside of that the component style to access the page's content or the component context as well. So if you want to select the host component, you can do that. If you want to select the host component with certain conditions on it, you can do that. And if you want almost like a parent selector for controlling the context of the component instance, you can style that as well. And you put that all in a style block inside of your Shadow DOM. Now, it's not completely insulated. Some inherited styles do break through, which I think is important because you don't want to have to customize the color, the font color, and so all the things there's a lot of properties that are inheritable that will break through that Shadow DOM barrier. But I think that's useful, and you can learn more about that on Chris Haynes' blog post there. But again, this introduces even more repetition in our component instances. So I really don't think that the declarative Shadow DOM folks have expected us to, or the standards folks have expected us to repeat ourselves by copying all of this stuff throughout our component instances. But it does kind of introduce this tension, right, between we don't want to repeat ourselves, but we still want the benefits of server-side rendering. So it's kind of this standoff, right? And JavaScript is right out the middle. JavaScript is the elephant in the room in this story. So let's talk about how to server-side render web components. So don't use this code. It's not real. It doesn't exist. This is what I would like to see. I would like a declarative way to have a single template instance be reused in different component instances on the page. So I want to take these pink sections here and just put them in a single template that I can reference. Does not exist. If you want to participate in the active discussion that's happening right now, you can go to the WICG Web Components issue there, linked, that I'm sure you could all read way in the back. But perhaps the spiciest slide of this discussion is that I really don't feel like SSR is sufficiently solved by the platform, at least not in the way that you can author these things from scratch. I think that we'll get there. It's just not quite there yet. But in the meantime, we can sort of farm that work out to the next level up from the platform, which is libraries and frameworks. So historically, there's been 1,000 blog posts written about how JavaScript framework authors don't like web components, don't use web components, despite treating them as a compilation target. And I really think that JavaScript frameworks and web components can be BFFs, best friends. Old best friend is JavaScript framework. New best friend is web components. And when you look at the different examples of component frameworks that exist, in the lower left quadrant, we have the compilation target audience. In the top right corner, we have first-party web components that do support server-side rendering. And then in the bottom right corner, there are two existing frameworks that I'm aware of that treat server-side rendering and web components as a first-party thing. And if you want to learn more about how component frameworks have good interoperability with web components, you can go to Custom Elements Everywhere. They have a test suite that runs. Just as a spoiler alert, this particular example does not have great interoperability with web components, and it's the only actively maintained one that does still have failing tests. So, Lit and Stencil, both first-party web component implementations and libraries, they have server-side rendering methods. You can check those out if you're using those. Enhance, if you go to enhance.dev, that's another one that treats server-side rendering of web components as a first-party thing. And WebC is the one that I work on in 11D. But Enhance and WebC do similar things. And I do want to go through just a quick example of just the thing that I built. Yay, that solves the problem of this talk. Sorry. There's a problem. I solved it. Okay, so when you're using WebC, you can combine component instances and component definitions. So in this example, we have a myCounter WebC file. We can embed our template, our declarative shadow DOM template inside of that, and WebC will process those on the server to output our generated HTML for us. So when we're authoring the components, we still get the nice benefits of not having to repeat our template throughout our component instances, and WebC will process those for us and copy it throughout. And here's perhaps a simpler example of WebC using more of a svelte style syntax. So yeah, you can have a style element inside of your component definition. You add a WebC scoped attribute to it, and we'll generate CSS for you that really sort of looks like normal HTML rather than Shadow DOM. So with WebC, you can kind of decide how much you want to lean into declarative Shadow DOM or JavaScript-based Shadow DOM or just standard HTML. And independent of which one you choose, you do get the same benefits of that nice authoring experience. So I am evaluating the thing that I built. Look, it gets 4 green checks. Great. It's server rendered. There's no library JavaScript here. There's no library JavaScript running on the client. We get the full benefit of encapsulation. We don't have to repeat ourselves, and we get progressive enhancement. So if you want to try this, if you want to try WebC out, you can go to our starter repo for that on the 11D GitHub. But just from a little bit of a higher level, when you're thinking about web performance, if you can do it in HTML, you should do it in HTML. If you can do it in CSS, you should do it in CSS. And as a last resort, if you can do it in JavaScript, do it in JavaScript. But this is when you run into performance problems, it's when you try to reorder these things or combine them in weird ways. So when you put CSS in JavaScript, as Sid mentioned this morning, you get performance problems from that. So really try and push stuff up the stack as much as you can to avoid performance problems later. Thank you.